Alright, so let's say you're given this diagram here, and the question says, you throw a massive 1 kilogram ball against a brick wall. It moves horizontally to the left at a speed of v equals 30 meters per second, hits the wall, and then rebounds traveling at a speed of 20 meters per second to the right. Find the impulse of the next external force on the ball during its collision with the wall. To start, remember what we know from last time about impulse, given by this equation here, where J is the impulse with units kilograms times meters per second, remembering that impulse is a vector quantity, and then delta P is the change in momentum, also given by this equation here, where P2 is the momentum at point 2 and P1 is the momentum at point 1. And it's also important to note that the momentum is also a vector quantity. So we can note that impulse describes the change in momentum of the object. We apply this to our example. This is our example here. If we apply the equation we just found, we need to find P2 and P1. We can do this by remembering that the momentum is equal to mass times velocity, where v is the velocity vector. So P2 is equal to mv2 and then P1 is equal to mv1. Now we need to identify what our points P1 and P2 are going to be in this question. So if we look at our diagram, we can identify the P1 as before the collision, and then we identify P2 as the point after the collision. With this definition, we can start by finding the momentum at point 1. We know that mass is equal to 1 kilograms. But what is velocity? At point 1, the velocity is 30 meters per second and it's traveling to the left. So if we define the right direction as positive, the velocity at point 1 is going to be negative 30 meters per second since it's traveling to the left. And so we can plug both these values in and we get this for the final answer for the momentum of the ball before the collision. We can look at what the momentum is at point 2 by identifying that mass is still equal to 1 kilograms, and then v2, if we look at our diagram here, it's going to be 20 meters per second and it's traveling to the right, and with our definition it's going to be positive. So if we plug both these values in and then do a simple multiplication, we get this for the momentum at point 2. So this is going to be the momentum after the ball hits the wall. We can plug both these values into our impulse equation, and if we do that, we can note that the negatives cancel, so it's just going to be an addition, and we get this for the final answer. So this is the impulse of the next external force on the object during its collision. One thing to note is that kilograms times meters per second is also equal to Newton seconds. So the impulse is also equal to 50 Newton seconds. If we draw our diagram of the ball's motion, we can identify that the momentum at P1 is equal to negative 30 kilograms times meters per second to the left. And then at point 2, the momentum is 20 kilograms times meters per second to the right. And this results in an impulse of 50 Newton seconds. Noting that the impulse of 50 Newton seconds being positive makes sense because since this impulse represents the kick that the wall exerts on the ball, and this kick, if we look at their diagram, the kick is definitely to the right since the ball travels to the right after, and so this positive value makes sense.